పేపర్ నాకు వర్షన్ 1 పంపించాను మీకు. అది పంపించాను నీకు.
నా దగ్గర లేదన్న, మొత్తం అది బ్యాకప్ పోయింది. అది
మీకు వాట్సాప్ పెట్టా.
ఓకే.
అది 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 ఏ ఫార్మాట్ అది?
ఓడే
ఓడేనా?
ఎదుగుతా అయితే పేరుతో ఎక్కడ కానీ. Okay, without wasting much of your time, we just start our
recording
session.
in progress.
Now, previously we are discussing about the history of the deep learning. So before going in depth into the history of the deep learning, so what basically a deep learning offers to the younger generations. So these are the three main areas which deep learning offers to you. One is detection. So the detection means text detection or speech detection, or text to speech to text conversion, or something. Or suppose you speak in a French, if you want to convert into English on while on the live. So for this detection, speech to language detection, language to language conversions, all such type of things will be done using under the detection, and image interpretation, and human behavior identity, and abuse and fraud. So here image interpretation and human behavior identity and abuse and fraud, I did some of the projects under the Center of Excellences, not from our college, actually from other side industry. So what industry wants is in image interpretation. So what kind of realistic problems we will we will get is, so we get we get an image. In that image we have a couple of icons. Okay, చెప్పనా?
తర్వాత మీ దగ్గర వస్తే వాళ్ళని పర్సనల్గా పిలిచి
వివేక్ సార్
సార్ వస్తే
సార్
వాళ్ళని రోల్స్ ఎలా చేస్తారు చేసింది వాళ్ళు పర్సనల్గా పిలిచి వాళ్ళకి ఏం చేయాలో చెప్తే వాళ్ళు
క్లాస్ అయిన తర్వాత వస్తారు 10:30 కల్లా వచ్చేస్తారు. అదే sorry. So there will be a number of images will be there. In the number of images we have to find what type of what it is. So it is called image capturing, and sometimes called image object detection, and most of the things will comes under detection, and human behavior and identity. So in the human behavior and identity, what actually the industry or the deep learning offers is, so there will be a there will be a gate points will be there. Gate points, we call it as a gate points. So a human is converted into a stick figure in a video. So basically this human behavior identity will observed in the CC dams, and so there will be eight points will be there. So 1 2 3 4 5 6 and 7, and this is 8. So they will draw an image of a person as a gate points. So now depending upon this depending upon the behavior of this stick figure, so they will identify the human behavior. This is mostly useful. This human behavior identification is mostly useful for the criminal detections and military areas and military purpose. So to find out any bombers, or to find out any malicious observer in the crowd. So in this regard they will use human behavior identity. So if you want to I will show you one small thing for that, because it is already existed applications are there. some of the existed applications on human behavior identity. So I will show you some of the human behavior identity applications. Just be on the screen, please.
Hello world, it's Siraj, and war.
So let me share my screen.
Robots. We're going to learn a bit about how military robots
So
work
basically it is
and then
for
teach a
robots.
simulated robot. Most there came from
You this.
using radio wave enhancement in military, or even feed the computed
So here-
coordinate to a weapon and have
This is about the deep learning architecture. In the deep learning architecture, so here we give an input to the deep learning model. So in the deep learning model, so it will find out whether it is a human or non-human. So it is basically a classification. So in any deep learning model, the popular technique in deep learning is a convolution neural networks. The convolution neural networks. So this is where the convolution process will start. So this is the input. This is the input you will give. This is the input. So where you will convert all your feature maps. So here what is generated here, what you will get is a feature maps. We call it as FM. So the feature map will fed to the fully connected layers. So these from this you can predict whether it is a human or non-human. Similarly, either it is a bomber or not bomber.
have its position adjusted accordingly and fire automatically, effectively using auto-aim. Reinforcement learning has been an effective tool to get robots to learn how to navigate virtual environments. Some soldiers go through extensive simulated training before being deployed to the real world, and an RL agent could prove useful as an unpredictable and adaptive enemy during combat simulation for a range of soldiers, from fighter pilots to ground soldiers. These agents could use techniques like Q learning or policy gradients or actor critic to learn how best to avoid enemy fire and even create effective strategies to confuse the enemy before attack, and generating a prediction for the next chunk, computing an error, backpropagating the error gradients, and repeating that process lots of times. Since recurrent networks are made for sequential data, audio is a perfect use case. After training, they can recognize human speech with incredible accuracy, and this is essential for mission-critical applications. Governments have mountains of data from surveillance systems and satellites of all kinds. Finding disturbances using unsupervised learning techniques like anomaly detection via autoencoders. War doesn't just have to happen in real life. It can happen online as well. Today, the process of finding and countering bugs, hacks, and all sorts of cyber infection vectors is still effectively artisanal. Professional security experts search millions of lines of code to find and fix vulnerabilities that could be taken advantage of by users with ulterior motives. All of this could be automated using deep learning to find the features of vulnerable code and learning to patch bugs by itself. So rule-based intelligence can only do so much, but by integrating learning algorithms, machines can become far more capable. When a human is in the loop, they are able to make the final call, the highest level decision. That's the one that the human makes. But as AI gets better, it's able to make more decisions for itself. So how many decisions should we delegate to AI? How much is too much? Take the idea of a swarm, for example. Any aircraft, manned or unmanned, can be brought down by a single missile. But a swarm can take multiple hits and keep going. It's a collection of drones that can coordinate together as a single entity. One could take out enemy systems, while the other creates a distraction, while the other picks up important cargo. Evolutionary techniques like particle swarm optimization can make this happen. The US Department of Defense recently released a document called Human Systems Roadmap Review that reveals a plan to use AI to create autonomous weapons using social media analytics to make decisions on lethal force with minimal human involvement. It shows that while having a human in the loop is necessary for the near term, their far-term vision is self-aware systems. They define this as systems that have perception, reasoning, and intelligence, allowing for entities to have existence, intent, relationships, and understanding in the battle space relative to a mission. That means drones that coordinate amongst themselves, make decisions for themselves, prioritize by themselves, and of course, decide who to kill and when to kill them by themselves. That's kind of scary.
Okay, so that's about in military applications. So these are all very limited because the military applications mostly are secured one. So only the applications what we learn, so we projected here. So let us back to let us back to the near applications again. So the another thing is the abuse and fraud. So the abuse and fraud is mostly used in the news and media, where they will find out social media. So they will find out what is it a fake news or a genuine news, because nowadays everybody knowingly or unknowingly, intentionally or unintentionally, they will forward the news what they received, and they feel that is worth sharing. But we don't find whether it is a genuine one or not, genuine one or not. So for that, it is very difficult for the human cognition to find out whether it is a genuine one or not according to their abilities. So to find out that, we have the Times of India developed one new technique called fraud. So there, if you post that tag there, so they will check whether it is a fraudulent one or non-fraudulent one. So such an application, some beautiful applications developed on deep learning. And another one is a prediction. So one is a recommendation. So whenever you purchase, suppose you purchase a laptop in Amazon. So on the next day itself, it will give the recommendations. So you buy a laptop, so buy the keyboard, mouse, or all the peripherals, it will display to you. So, or else if you search something in the website on the Google, so automatically it will give you recommendations to you. So watch this in Netflix and Amazon. So whenever you watch any series, so automatically you may get some recommendations to you. So this is basing on the recommendation systems what we have, and behavioral conditions and the collective behaviors. So these are all because comes under social engineering, where what they will do is they will test the human psychology things. So here what they will do is, here they will put one what you call the electron sensor. That sensor will keep on your head, so they will record all your emotions and how your brain is reacting for that. So they will understand. Mostly this is applicable for the criminal identification and criminal behavior detection. So the next one is generation. So visual arts, which means the theme and arts and music and the text and the design. So these are all developed by the deep learning. So we have a adversarial networks, GAN, generative adversarial networks. So these adversarial networks developed a movie also. So artificial intelligence developed a movie also. In that movie, I will just have a glimpse of a movie of it. Okay. So what it is developed is it developed the actor's face. Okay, it developed the language. It developed the script. Okay, it developed the script, and it developed the script, and it is directed and music also. So some of the this is the video I'm showing to you.
This movie was
I hope
made by
this is
AI.
visible to you.
The script was written by AI. And the characters were designed by AI.
Please, Matt. Don't leave me.
I'm sorry, Jenna, but I'm looking for somebody a bit more brave.
See,
Somebody
this is
who faces
animation.
her fears
So
head on
animation
instead of
is
running
developed
away.
by-
I'm such a
this is
person.
animation.
I'm sorry, Jenna.
Animation is developed
I just don't feel
by
excited by this relationship
generative
anymore.
adversarial networks. So this animation movie is developed by generative adversarial network. So you better watch once.
Goodness, Carla, is everything okay?
I'm afraid not.
What is it? Don't keep me in suspense.
It's a ghost. I saw an evil ghost frame a bunch of children.
Defenseless children?
Yes, defenseless children.
Bloomin' heck, Carla. We've got to do something.
Because you found out that there's a mistake. Actually, it is a gender. The right side is a female gender, but the due to the AI is not developed that much rapidly. So that's why you find some of the bugs like the mustache for the women's and faces morphing and all that sometimes because it is developed by AI.
I agree, but I wouldn't know where to start.
You can start by telling me where this happened.
I was.
Focus, Carla. Focus. Where did it happen?
Quality Cafe, Los Angeles. That's right, Quality Cafe, Los Angeles. What is this? What's the matter?
That's not just any old ghost. That's Beth One.
Who's Beth what?
Who's Beth One? Who's Beth One? Only the most cowardly ghost in the universe.
Jenna. We're going to need some help if we're going to stop the most cowardly ghost in the universe.
You can say that again.
Jenna. We're going to need some help if we're going to stop the most cowardly ghost in the universe.
I'm going to need steaks. Lots of steaks.
Wahaha. Jenna Parks, we need to bed.
Okay, this is actually an animation one. So I would like to share you one with
You've met?
human beings.
This is how fast YouTube is with Brave. Notice how there's no pre-roll ads?
Screen.
And here
So what they did is, so these are the list of movies. Let me pass. These are all the list of movies. All the scripts is fed to the generative adversarial networks. So that is basically developed on the recurrent LSTM with the recurrent neural networks. So what it does is basically any neural network. What it will does is, depending upon your input, depending on your input, it will predict the output. It will predict the output, what comes next. So you can use that prediction for any purpose of thing. So for the text and music and video or some anything. So here they fed all these movies. So in the right side you can see this Oblivion and Perfect Creature Pi. So Pitch Black, as Darko. These are all the movies they fed it to the recurrent neural network, and at the end it generates one movie script for movie script and the movie. So look at here. So this experimentation is done in US with the funding agencies from the Warner Brothers. So this is the screenplay. If anybody is interested to see the screenplay, so this is the screenplay. It is given by this screenplay is given by the AI. This screenplay is given by the AI. So it has automatically created two characters, two to three characters, and every character it generates the dialogue and the scene motion also. So let us see how it is how it done the movie. This is basing on the deep learning technique called LSTM and a recurrent neural network.
In a future with mass unemployment, young people are forced to sell blood. It's something I can do.
You should see the boy and shut up. I was the one who was going to be 100 years old.
Sometimes you may see in the faces
I saw him again.
will changes.
The way you were
because
sent
the
to me.
generative adversarial network
That
will
was
build the face which
a
is
big,
nowhere exists
honest
in the
idea.
world. These are all actors are not existed.
I am not
They are
a bright
generated
light.
by the artificial intelligence.
Well, I have to go to the skull. I don't know.
basing on the traits which is given by the.
Ooh. Huh. What do you mean?
Well, I don't know anything about any of this, so.
Then what?
There's no answer.
We're going to see the money.
Basically, if you see, okay, let me complete. So it's get boring because artificial intelligence generates the scripts which is not having any emotions. So emotions are not added in it. So because that's
be
why
forgiven.
the scenes are not that much.
I'm not gonna
what we
do
watch in the
something.
regular movies. They are like some.
I was so happy and blue. I was thinking of
And
you.
that song, what you listening in the backside, that is also
I was a
generated by
long,
the AI.
long time. I was so close to you. I was a long time ago. I was ready to go.
So I'm sharing this screen to you, this movie to you. So 523, please be there in your room. I'm sharing this link to all of you. So if anybody interested to watch it more, then you can do that. So that's about this basic thing about this deep learning. Now we'll look into we'll dive into the deep learning thing. So the basic deep learning thing, I borrowed these slides from the NPTEL. So that is one beautiful course in NPTEL called Deep Learning Technique. So they gave a beautiful introduction to it. So in the so the deep learning technique, it is started in 1871. The basic of deep learning is started in 1871. So why deep learning is evolved is why that much is. So they want to know, they want to build one system which acts like a human brain, which acts like a human brain. So if you want to create one application which is acts like a human brain, first of all you have to understand the human cognition. So that way Joseph von Gerlach, he proposed a nervous system at a single neuron system. It's a single neuron system. So it will give depending upon the input, it will give the output. So here the input and output depends upon a linear function. So again, in 1873, Camillo Golgi is created one chemical reaction. So, depending chemical reaction, how one neuron will communicate with another reaction like a chemical reaction. So he proposed one theory called a reticular theory. In the reticular theory, what is on the right side? What you are seeing is a drawing, because in 1871 and 73, it is mostly on arts written in hands. So there the neuron, the right side, all this branch tree-like structures. These are all. So yeah. And these tree-like structures are called neurons. How the neuron is interact with another neuron, how the information is traveled with one another. Though again in from the 1871, from the reticular theory, there is another theory evolved that is called neuron doctrine. So the neuron doctrine, so it is proposed made of discrete. So here the thing is, here if the all are in chemical reaction, so every neuron will be active. Then at some point of time the neurons will be dead, but it is not happening though. So there is something else which is happening in our brain. That's why the neuron doctrine came. So here what is it? The neurons will be discrete, they will be connected, but not all will be activated depending upon the input. So some of the neurons will be activated, some of the neurons will not be activated. Then the term neuron is coined in the year of 1891 by the neuron doctrine by the Wilhelm Gottfried. Now comes to the main thing. So in the Nobel Prize, both Golgi and Kagel, they got a Nobel Prize. So what basing for the how the human brain, the human neuron will communicate with each other with a scientific evidence. So that's why they got a Nobel Prize for that. Now in the final stage, though in the electron microscopy, finally they confirmed the human doctrine. That is, the nervous cells were individually interconnected to the another one. So in your brain, every neuron will be interconnected. Every neuron is connected to the another neuron. So that's what the neuron doctrine is saying. But what they said is, in addition to what they said is, depending upon the input. So there will be a there will be only activated neurons will be there. So coming to the AA. So if I start about the AA, the first and foremost thing I have to start with the Michaelis-Pitt neuron. The Michaelis-Pitt neuron, Michaelis is a neuroscientist. So Pitt is a logician, which means a mathematician. They proposed one simplified model of neuron. So here x1, x2, x3 and so on are all the inputs. They're given to one function that is called g of x. Now this g of x will generate one function called f of x. Now this f of x will give, we have a two states, either true or false. So this is basically truth table based. So for understanding purpose for you, I'm saying that it is basing on the truth table purpose. So here suppose my function, the function inside the neuron is a exclusive or, suppose exclusive or depending upon the relation of the input. So you will get either 0 or 1. So for this 0 or 1, which is for binary purpose only, Michaelis-Pitt neuron is generated. It is generated in 1943. Then the perceptron evolves. The perceptron is able to learn, make a decision, and translate languages. So the advanced version of Meckel's-Petri neuron, is a perceptron. Here, the main difference between, see, this is Meckel's-Petri neuron developed in 1943. Then the advanced version comes in the 1957. So in the 1957, what it is do is it will take the decision whether it when what is the relation between x1 x2 and so on xn, and they will give a weights for that, because of which input I need to consider for the most effective decision, and which input I need to consider for the most ineffective decision. So we'll give one example for that. So this is how they created one embryo with the electronic computer with the perceptron. So let us take one small example for you. Why weights are required? Suppose you are traveling on a bike. No, sorry, you're traveling on a car. Okay. At a point, you saw one child, two, one pregnant woman, three, one old lady, four, a blind person, a disabled person. And six, your family member. So you're traveling on a car. At a point of time, you saw these six members. In your car, you have a three places, because every car is have a four capacity. Consider it is a standard one. They have four capacity. So you can choose only three of because already one is occupied in a driver's seat. You can select only three of it. So now tell me, anyone can give in the chat session. So which options you can choose? So 1, 2, 3, 4, 5, 6. Which options you will choose? And sorry, one more is also there. Declares. Yeah. Now the chance. Now the quiz is open to all. Now tell me, which person you will ask first. You will take into your car. So give your answer in the chat session. 2. Very good, Ruchita. I am expecting I'm expecting some of the answers from all of you. So you can choose. Three persons. So not a single one. So choose 3 persons. So guys, please respond. I'm copying this screen and saving it. Oh, nobody is giving any response. Why? Are you there in the class? So the thing is like this. So whenever you join in the second session, whenever you join in the morning session, so in my class the rule is like this: if it is online, so while you're joining at 9:15, before 9:15, yes. If it is 9:10, 9:15, which means anytime the 5 minutes after the before 5 minutes, so you have to give the attendance. And while you're joining the second session, which means after the 40 minutes again, you have to give the attendance. So the next 40 minutes, if the meeting ends, please join it and give the attendance there. Okay, we give the attendance.
Recording in progress.
Okay, I'm just muting all because I'm seeing all the concerns here and there. So let us share the screen again. Yeah. Now we are discussing about Meckel's pet neura. From that, the Rosenfeld perceptron. So this is the Rosenfeld perceptron, which is designed using transistors. Now, the Ivanko is generated one advanced artificial intelligence that is called multi-layer perceptron. Multi-layer perceptron. Here, this is a single layer perceptron. The single layer perceptron only one perceptron will be there. It will make the decision. So here the decision will depends. Here the decision will depends upon the weights. Here the decision is depends upon the weights. So the question what I asked is also depends upon your human cognition weights. If I say frankly, it depends upon your depends upon your locality and your cognition of your brain cognition of your brain. So the choosing of the options will be there. The choosing of options will be there. The choosing of options will be there. Okay. Choosing of option will be there. Okay. Now let us assume this type of perceptrons is connected one or together. Then how the resultant decision will be. So this is exactly how our brain will works. So similarly here our neutron will receive the input and depends upon the weights. So mostly 80% will be the priority based. Our brain will think on the priority based or the need based. Priority based or the need based. Okay. So this is a multi-layer perceptor. This is the multi-layer perceptor. Here this is the input. This is the input layer, and this is the hidden layers. First and second and third hidden layers. So these are all the perceptron. These perceptrons will think and judge the output. Judge the output. Here there is one thing is missing in the multi-layer perceptor, that is called bias. Bias. Bias, because for every thinking we thinks that it is a biased one or non-biased one, which means where you are leaning to. So some neurons, some perceptrons will thinks that they will lean to one of the statements. So these may be a classes here, x1 x2 on xn. These may be a classes, or these may be a class labels, or these may be a statements, these may be any signals, whatever it may be. So depending upon it, this perceptron and the perceptron will have an activation function. And perceptron will have an activation function. Every perceptron will have an activation function. Activation function. If the activation function, if the input is satisfies the activation functions, then the output will generate it. Output means here the output is also a zeros and ones. Here the output is also for every perceptron. The output is also zeros and ones. Okay. Now the MLP will give a cumulative decision output. So this is the starting of our the multi. If I say frankly, this is the starting of our deep learning era. So it is mostly on 1965. So we multi-layer from the generation of multi-layer perceptron. So in a computer science, we call it as the deep learning evolution started. So from there they generated one perceptron. So you can find out this perceptron book. You can find out this perceptron book by Minsky and Papret, and its limitation in open access PDF drive. Now, what happened is from the 1968 onwards. So after the perceptron is evolved, so there may be a no light in the tunnel. So up to 1986, because nobody is actively involved in a generation of artificial intelligence and generation of the more advanced perceptrons and more advanced multi-layer perceptrons. So at 1986, at 1986, then one new is started by the Verbose. So he used one term called artificial neural networks. He used one term called artificial neural networks. Eventually, they are popular in 1986. 1986. What it is a back propagation. Back propagation. What is meant by back propagation is, suppose you made a decision. Suppose using the inputs. Imagine this: using the inputs, you made a decision, and at point of time you found out that that decision is wrong. Then you go back and adjust the adjust. What you will adjust? You can't adjust the input. You can't adjust the neurons. What you can adjust? You're gonna adjust the weights. Weights depending upon, if you think that depending upon the weights only you arrived that conclusion. So if weights are adjusted, then your conclusion will also changes. Your conclusion will also changes. Your conclusion will also changes. Let us suppose think that you want to kick a person. You want to kick a person. So if I say that person is very lean and tall and very calm and nothing, he doesn't have any background in it. So definitely anyone with aggressive nature, they will go and kick it. So if I say that, so that person is stubborn and the person is a muzzled and he have a six pack body and he is very trained in the battle. So most of you is not will not go to quarrel with him directly. Quarrel with him directly. So if I say that that person with a six-pack body and with abs and trained in war is a person is a son of an MLA, then most of and almost 95 to 98% people will not return him in an open quarrel or battle. Suppose if I say that he is a son of a CM or a PM or anyone, any national's higher authority person, then you won't see him in any manner. Okay, you won't have any problem what he does. So this is depends upon your perception. This is depends upon your perception, basing on how your weights are adjusted. How your weights are adjusted. Weights means here your perception, how your perception is adjusted. So similarly here also in the back propagation, what the neurons will do is, here the neurons will adjust the weights depending upon the loss function. Depending upon the loss function. So the new term called the loss function. New term called loss function. Okay, how it is generated the loss function? What it is? Because in a computer everything is a zeros and ones. Let us suppose you gave zero as input. Zero as input. Zero as input, and that model predicts as 1. Now it is a wrong prediction. It is a wrong prediction. Because how it is know that it is a wrong prediction? Because under supervised learning, which means because you are supervising it whether it is a correct or not. That's why it is called under supervision. You gave a feedback or a ground truth to the model. Then model will decide that, oh, I did a mistake. The user give the input as 0 and the expected output is 1. The expected output is also 0, but I gave a 1. So here I need to adjust. So what is the loss? Generally the loss function, the general common loss function is original value minus predicted value. Original value minus predicted value. Suppose for a 0 input, your expected the original output is 0, but the model predicts 1. So 0 minus 1. So the last function is minus 1. So until unless the last function is minimized, so last function have a value. Until unless the last function is minimized, which means the last function reaches to 0, nearly 0, equivalent to 0, then this model will go forward and backward, backward. So the model is going to the backward and adjusting the weights, adjusting the weights and bias is called as a back propagation. Back propagation. So one forward, so going forward is called a feed forward neural networks. Going backward is called a back propagation. So going forward and coming back is called as one complete iteration. One complete iteration. Now, this is the most interesting. This is the most interesting development which is done by the Kashi. So here he developed one algorithm called gradient descendant algorithm for learning the neurons, because neurons are learning something, because we are giving the input depending upon the weights. So the weights adjustment, we call it as a learning. So how the weights has to be adjusted, in what capacity, in what extent we need to adjust it. So how to do this? This is given by the gradient. This is studied by the gradient Cauchy. He gave one algorithm called gradient descendant algorithm. So from where we need to start learning, which means if the neurons are adjusting its weights, from where it needs to adjust it, from where it needs to adjust it. So initially we need to give some values, right? So from the initial values only it will be adjusted. So after the initial value, from where it has to go, so up to what extent it has to change. Okay, so this is given by the gradient descendant algorithm. Gradient descendant algorithm. So all these are all there in your syllabus, so be cautious in it. And then another one is universal approximation algorithm. So this universal approximation algorithm is started in 1989. So this is the basing on multi-layered network neuron with a so here they will approximate the values. Here they will approximate the value. So the right side, the top corner, it is an approximation. See, we give a signal to we given one signal to the neuron. So see the deviations of the neuron. See the new deviations of the new neuron. Now the era of deep learning is started in the 2006 onwards, from the paper called unsupervised pre-training models. Unsupervised pre-training models. So there they developed one auto encoders. What auto-encoders will do is, if you see the right side image, the top image is a very blurry one. See, this is very blur and this is very sharp, because to compress and to decompress, which means to reduce the data dimensionality, to increase the data dimensionality, we require one neurons deep neural layer. So that is called that neural network is called auto encoder. So here this is the process of decompression. In the process of decompression, you will achieve the better quality. Okay, so we stopped here. So the next things we will discuss in the next class. I hope you understand the perceptron. So I'll give you some assignment on Michaelis-Pitt neuron. So you have to do that. So in the next class, I will give you that assignment. Okay, I'm stopping my share. I'm stopping my screen. So if you have any doubts, you can ask me now. Any doubts? Okay, if you don't have any doubts, we can leave for today. Thanks for joining the class. So mostly in the next class, we will see face to face. Okay. Bye. Now your golden era is stopped. I think so. So you have a classes from 6th onwards. I hope you received the mails from in your official mail. From 6th onwards, we have a physical classes. I think so. So we will meet you there on the 6th.
Recording stopped.
If you have any doubts, you can ask me. Okay, Disha, no problem. I saved it now, so no issue, Disha. Okay, thank you, 1222. Thank you for that. Okay, we'll meet you in the next class. Bye. In it, it'll turn in there. Bala. నేను తిన్నది నేను ఉంచుతున్నా.